So, welcome everybody to this Let's Build session on FHIR and GraphQL Mesh by Yuri. So Yuri is calling in from Greece. It's afternoon over there. To our people and our visitors from Asia and the US, you'll have different time zones, so welcome. And without further ado, I'll let Yuri introduce himself, and I'm looking forward to this talk. You can take over, Yuri.
Yes, thanks everyone. Thank you, Gustav, and hello everyone. Thanks for having me again. Yesterday we had a very large talk and with a lot of participants, a lot of questions. So what I'll try to do today, and I think there were a lot of questions. I answered a lot of them later on in the chat. But today, and the plan was for today for me to basically go step by step and build basically the example app that I showed yesterday, really step by step. And I could still do that, but I thought actually, because of all the questions and because of all the interest, I thought to maybe still do like a short overview today as well. Like I'll go through the same slides, just like way faster. And I'll demonstrate building the app, but I'll also do that much quicker than what I planned to, mostly because it's completely open source and it's also relatively simple, as you can see. So you can just try it out yourself at any point. It's completely open source, and you can even try it out together with me today. And my goal for all of that is to get into actually questions as soon as possible, so we'll have as much time for questions today, because I think actually all the questions that got asked yesterday were really interesting, and the answers were really interesting. So I think the more time we'll have for questions, the more it will be fun. So that's what I'll start doing now. I'll just share my screen. I'll go way quicker. I'll go way quicker with my slides. So sorry for going very quick with the slides. But anyway, the goal is to get to questions as soon as possible, and you can ask me questions on everything later on. So yeah,
we can see your screen. We can see your screen.
Okay, good. So I'll start. So yesterday I gave a short intro about GraphQL in general. I'll do it today, but super quick. And also you can basically watch the recording from yesterday. But then I talked a bit about how we and the company that I created, because we are part of the GraphQL Foundation, and we were part of the building of the spec. We went back to the basics and look at it a bit differently, which created a lot of new opportunities that you might, even if you heard about GraphQL, you might didn't think about or heard about, and how it's all related to FHIR. Like recently, we started working with many clients and companies and hospitals in that area, and we saw a lot of demand for it. And also, I've talked a bit about kind of like new opportunities in that field. So I'll skip the part about us. I'll just say we're the largest open source group in the GraphQL world. I was part of the building of the spec itself. And somehow we got recently to work with, not so recently, we got to work with the FHIR protocol. And we saw that after creating some new concepts and ideas in the GraphQL world, we could actually utilize that with the FHIR protocol and the FHIR community. So just quickly about the basics of GraphQL. GraphQL is a query language over any data. So basically, you can describe your data in a schema, and the data source can be any data. Like it can be data coming from databases, from APIs, from local files, from Excel spreadsheets, any data you can think of. And then just by describing that in a certain way, the GraphQL engine can let you query it. And when you query, you get just the results that you need in the shape that you need them and in the type that you expect them to get. So that's a very powerful thing, because you can build a lot of developer tools on top of that. And the classical GraphQL solves the problem of overfetching, like we call an endpoint and we get a lot of data. And in GraphQL, you get to pick and choose what you want. So you get just the things that you need, and that's it. But also there's the problem with REST, which many times you want, in order to render a whole page, you need to get a lot of different sources. So you need to call many different endpoints. With GraphQL, you can basically describe your full intent in one query and get back one single result back. And because the spec is typed, the protocol is typed, you can build a lot of very powerful tools on top of it, like what you see here, which is a print screen of one individual tool, which basically gives you kind of like an IDE. If all that data exists locally for you, you get autocomplete, documentation right inside your code, and even error handling. But this is for data that might sit across the ocean with a team that you don't even know and you don't have any control of. So it's a very, very powerful thing. And this is just one example of like dozens of developer tools like that, just by the nature of the protocol. So it saves a lot of work and makes people that usually, or let's say, not only the developers are more productive, but also it makes it possible for people that are not developers to actually start exploring the data and decide what queries they want, which is, yeah. I'll skip a bit about the history. I talked a bit about how Facebook has invented it, but now it's open. It's in the GraphQL Foundation under the Linux Foundation, and many companies are using it. I also describe a bit about the internal process of how it works. I'm going to skip that part, actually. Let me jump. I also described a bit like the automation that this thing works. Let me just jump into that part really quickly. So everything you see in that slide is happening automatically by GraphQL. I went deeper into it in the last session, where by describing just how to fetch each field, and it can, again, each field can come from any data source and they can all be different. Everything you see here, GraphQL does automatically by getting a query. So GraphQL would analyze the response of the first user object and then execute that user object in parallel for each field that we described. And then for the messages, which we might get a number of different messages, like 3 messages, GraphQL will execute those in parallel and do all that work for us, which today we're probably doing manually. So this thing, everything I've showed you here and the background that I gave before, the question is, how could you utilize that? And where could it help you? And when we came and asked that question, there's many different answers for us. Usually the first answer is coming from the answer to the question, where are you writing that logic today? And what's interesting is that today I'm going to talk about 2 possible use cases. One is that in many applications today, we call, let's say, a FHIR server on the web or mobile app. We fetch all the data that we need, and then we're doing all that work that I've just showed you manually. Manually meaning writing code in order to construct the data into a certain way that we could display it, or construct the data into a certain way that we could process it in our data pipelines or whatever. So what we said is, maybe we could, unlike the classical use case of GraphQL, which you have a client, a GraphQL gateway, and data sources, maybe we could take that work and we could execute it anywhere. For example, on the client itself. And that's actually something that, since we started doing it, we worked with many companies well known in the industry, that actually that's the way that they started using GraphQL. They just used it locally on the client just to basically automate a lot of the work that they're doing today, and also to slowly build the data graph of the app. Like today, every app has a data graph. It's just hidden in code. But if we can describe it in a schema and automate a lot of that work through queries, we also get a very clear view about what is the data graph of our product and what it is comprised of. And that's a very powerful thing. Now, just to like mention something important, like if you think it's just like a small cool library, is that we worked with PayPal at the beginning, and PayPal found that UI developers in that case were spending less than a third of their time actually building UI. The rest of the time was spent figuring out where and how to fetch data, filtering and mapping over that data, and orchestrating many API calls. Now, or back then, building UI was a nice to have or an afterthought. And when we started building, working with them on GraphQL on the client, if we put aside all the overfetching and all those things that people, the benefits that people usually talk about GraphQL, but what we actually help them is to automate 2/3 of what they say is 2/3 of the work that they're actually doing. And that brought them a lot of benefits. They moved way quicker, and then later on they were able to move all that work into other parts of the stack and get even more benefits. But here specifically they talked about UI developers, but what we also see is and one other very important thing is that it was very easy to integrate GraphQL that way, because we didn't need to add a new server or change the network architecture or anything like that. They just needed to install a new NPM library or a new null library for JavaScript, and that's it, like any other tool that they had the authority to do anyway. So it was also organization-wise, it was much easier to integrate and bring it into the organization. But the same benefits that those UI developers were talking about, we saw the same on the backend side. So we saw the same in, for example, data processing teams or like machine learning teams, because what they do is a similar kind of work. They take a lot of different data sources from a lot of different places. They want to get the data in a certain shape and in a certain form, and then run their experiments or their algorithms on it. And they saw also a lot of benefits in GraphQL. But what we started seeing on the backend is, because they saw that those benefits, they started advocating for all the different existing services to all migrate and expose GraphQL, or to maybe build like small new GraphQL gateways in front of each data source, which if you're a small company and you have all the time in the world might make sense. But in real world, there's endless amounts of data sources out there inside your organization and outside of your organization, and we want to use them today. And probably those teams that works on the data sources might be actually sometimes not existent anymore. And also, if they're existing, they have enough work as is. They don't have the time now to integrate a new protocol and those things. So what we ask ourselves, working with those teams, with those data processing teams, is could we get the same idea? Could we use GraphQL where they want to use it, like as the consumers, but utilizing all the existing protocols that they have? So the idea was, and that's the idea that I presented yesterday, was could we take all those different sources and whatever their sources are exposing, they might expose an open API spec or Swagger, they might expose a gRPC endpoints, maybe they have JSON schema, maybe they're having FHIR over JSON schema, maybe they have FHIR over XML. So we could take all those different things, we could automatically convert those into GraphQL schemas, into data graphs. And then automatically, once we have all those different sources, maybe we can also merge all of those into one individual data source that we could query, and create basically one graph with one language to describe that graph, but the sources could be endless. And that's the GraphQL Mesh library. We introduced this a year ago, and since then we've been working with, the adoption was the biggest that we have on any of our libraries. And we worked with teams like the Microsoft Graph teams and other teams, because this idea was so powerful. And I'll describe more about that now. So again, the idea was that you get the query language and the developer tools. Like you get to query GraphQL, send GraphQL queries to your but it's all on top of existing services. You didn't need to build a new GraphQL server. It was generated for you. And another very important point here is that this GraphQL execution, this thing that calls all those different sources, merge them into one thing, and provides you the result that you expect to get, the result of a GraphQL query, could be run and executed anywhere. So you don't necessarily need to build a new to create a new server or a new gateway into your architecture. You can actually just generate an SDK and run that code on your mobile app, or run that code as part of the data processing service or the machine learning service. So now you didn't have to change any of your existing network architecture and any of your team structure. You didn't need to bring in new experts or anything like that, but you could use a lot of the benefits of GraphQL. So again, what GraphQL Mesh is taking all those different sources, and the first phase is to convert that into the universal language called GraphQL. But later you can even do more. So what you see here is, let's say I took two sources. One is an event source, and one is a list of cities and the information and the weather about those cities. So now I can query each of those in two separate queries, and that's fine. But what I really want is I want to actually integrate those two graphs together. I want to actually create connections between different graphs, because then what I want is I want to query for an event, and I want to create for the weather of the event in the event's location, and I want to query it as if it was one source, even though behind the scenes those are two sources that are completely individual and don't know about each other, and actually might, thanks to GraphQL Mesh, actually don't even know what GraphQL is. So that's the power of GraphQL Mesh here. And what I said before about running anywhere, again, you can create this like central gateway that merges all the data together and expose it into one graph. But you could also just generate it as SDK, and again, get the same experience, but completely distributed. So you can run it on the client, or you can run it on your machine learning service. And they could look at the whole graph and query the whole graph, but those calls are don't need to go in through a central service that might, what might fail or might add a new thing into your architecture. And so GraphQL Mesh supports, OpenAPI and Swagger, gRPC, SOAP, and many others. OData, I mentioned yesterday that we worked with the OData was very interesting because we worked with Microsoft on that. They have an API called the MS Graph, which is basically an API of all the data for all the applications in Microsoft. It's written in OData, and we were successfully able to convert it to GraphQL, so everyone can now query GraphQL for the MS Graph. And they specifically created a project to do that 2 years ago and failed. So it was very nice and very fun to work with them on that problem. And recently, we added the FHIR handler. So it's based on actually the JSON, both on a bit about the SOAP handler and a bit on the JSON schema handler, with some small features that make FHIR which makes the lives of FHIR consumers much easier. So today I wanted to basically walk with you and actually like build the app with you. But yesterday, again, like I said, yesterday, there were a lot of questions, and even though I answered all of them on the chat, I thought, I could actually expand more on those questions. And the other reasons I thought not to put the whole time today on the example app is because this example app is open source. Like, let me just show you what I thought today is basically to start from scratch here. And to basically build this app, which what I'll do is basically just I'll walk through it really quickly now. But what you could do is just, if you go to let's say graphqlmesh.com, and you can do it now, by the way, with me. You can even start building this app now, because this app basically takes 20 lines of code. And then go to GitHub. I hope you can still see my screen. And then go to examples. You can see here a JSON schema FHIR example. And you can just download it and run it, and it's completely open source, and you have also the example queries here. So yeah, so you can just try it yourself, and if you have any issue, you can just open an issue or reach out to me directly. So I'll just go through it super quick, and then I want to get into questions. So if we are starting really from scratch, all we need to do is just to create a package JSON, just to have a server to run on. And by the way, this is JavaScript. Everything you see here is JavaScript, but we have more internal applications that do the same in other languages. But because the sources can be any source, even if the sources are in any other language, it doesn't matter. You can still use the same thing to run, to query it. So it doesn't really matter what language, what programming language the source is. So all you need to do is basically start this package JSON, which means you just run npm init. Let me open a terminal here. Yeah, I'll do it super quick because I want to get to questions really quickly. But basically, you run npm init. You can do -i, so it will just won't ask you a question and create one automatically. Then we just need to install GraphQL Mesh CLI. So we can just do like yarn add GraphQL Mesh CLI and GraphQL, and that's it. And then once we have that, all we need to do is to start writing this file. This is the center of everything. This GraphQL Mesh rc.yaml file. And if I'll remove, I'm gonna like exclude all of that for a second. Then this is just to get the first version working. That's all you need to do. You just need this thing. Let me even see if I can run it right now. What you see here is I just tell GraphQL Mesh, I have a source. This is just the name. We'll call it FHIR or whatever, but it's from the type of FHIR source, and I'm giving it an endpoint, which this is like the happy FHIR server that you probably all of you know already. And now just by doing that, I have a working GraphQL app that runs top of this thing. That's it. That's all we needed to do. And we can start querying GraphQL from this thing. I'll just go to I have a video for it just so like we can jump quickly. I'll just show you what you get when you get this thing. Because my computer is like thinking hard, getting stuck from all those different things that I'm running. Just a second. Sorry about that. I hope you can still hear me. Okay. So let me just show you. Yeah, so what you see here is you can see that I have a fully running GraphQL endpoint with all those everything you see here comes from the original server, and it's a full generated docs. I can search for, whatever I want, like patient, or, and I can see if I query for a patient, what I need to query and all of those things. And I can start querying those things. So let me just I'm going to skip this part and I'm going to return all of those just so I can start. Maybe because I feel my computer it's up, so I'm going to go back here and try to, maybe this will work better. But again, you can run it yourself. Yeah, see here. So what you see here is just by doing those 4 lines, I can query GraphQL from a server that is not GraphQL at all. Yeah. So you can see I'm searching even for a specific patient or a number of patients. And now I got all the different patients that they have Jane in their names, and I got their given name, family name, and only the things that I want. So and so that's extremely powerful, right? Like nobody wrote GraphQL here, and we got GraphQL. But then, what I wanted to show you after that, and again, this is all open source and just a few extra lines of code, is that I added another source called COVID, which is actually like cases of COVID on specific locations, and I connected those two. So now I can, ask for in one query cases of COVID, let's say in the address of a patient, or cases of COVID in the address of a clinic, or something like that. Let me just show you the example. Yeah, what you see here. So so that all of that I demonstrated yesterday, and there's not a lot of code here, so there's not a lot to show. So I want to jump into questions because there's so much we could do here, and it's just the start. Like we already implemented it in a couple of projects that are living right now in production. Some of them are actually running on the mobile applications themselves because we worked with the mobile developers to move fast, even though the servers weren't in a position to even think about GraphQL at the time. And some of them were with all kinds of projects that did a lot of data processing and machine learning from a lot of different sources. And it basically saved them a lot of work of connecting to all those different sources, bringing the data that they need, and start the processing work that they actually want to do. So yeah, so I'm gonna stop here and go to questions to leave as much time for questions as possible. I skipped a lot, but the good thing is that yesterday's session was much more complete because I wanted to give time to questions today. So yeah, so I hope you have a lot of questions and I try to answer all of them. Thank you.
So thanks, Yuri. So you've got a bunch of questions in your chat, in your Zoom chat, actually.
Okay.
I can read them out to you. So the first question was, what is the performance of GraphQL Mesh? So that was the first question we had.
Mm-hmm. Oh, I see. What the performance of GraphQL Mesh? How does GraphQL Mesh interact with API? Okay, so the performance, that's a hard question to ask because the performance of what? But basically, there's a few different places where you can run GraphQL Mesh. You can run GraphQL Mesh as a gateway, and you can run GraphQL Mesh as an SDK. And in each and where you put that SDK also matters in terms of which performance you care about. So I'll touch each one of those and the performance impacts on each of those. So first of all, you could use GraphQL Mesh as the classical use case of GraphQL, meaning you can take all your different data sources inside your like gather all your different services, expose them all as one gateway, and then expose that gateway outside for applications. So in that case, what you want is less processing work over the incoming request, because the performance that you save anyway is the network performance over the network. So here, GraphQL Mesh saves you a lot of like, let's say if you're using a lot of mobile devices or you're calling a lot of requests over the network that is not like a very fast network, it's great to do so, but you also want the processing work to be as little as possible. Here, I would say the performance is extremely well because we're actually running it in many different applications, and it's built on top of let's say, the processing and the merging strategies is built on top of another technology that we write that's called schema stitching, that for many years was technology that was being built by another company. They neglected it. We took over, we completely rebuilt it, and today we have a lot of very famous libraries running huge gateways and huge loads over schema stitching. So the performance is fairly well. But again, like, there's many different benchmarks, and we would love to see a benchmark where you see if that's not the case. Also, each part of that pipeline is completely customizable. So adding caching to results or adding caching to resolutions is possible. So in case you have a problem there, it's very easy to solve. Another part is where you run this as an SDK, and then let's say if you run it as an SDK on a web app, you care about bundle size in terms of performance. You want that bundle size to be very small. And here as well, what we've done is that we changed a lot of the inner dependencies that we had. So today the bundle size, even if you take all that gateway and you actually bundle that as an SDK to a web app, even the bundle size is pretty small. So I guess the performance impact, in my opinion, is very small. And we also have more optimizations that we want to introduce in the future. So my currently, at least throughout all of our current clients, the performance impact was, I would say, was for the better than for the worse. But it's open source, so we keep getting more feedback and we keep wanting to improve it, and we have a long list of things we want to improve on that sense. Yeah. Okay,
I think that was really long, good answers. So I think the second part of the question you seem to have answered. So that was, how does GraphQL
I see. How does the GraphQL Mesh interact with an API gateway? So again, there's GraphQL Mesh itself can serve as an API gateway, but it could also sit in front of an existing API gateway, or even as an SDK on the client. So it depends on your use case, and it also depends on at what stage you are of the adoption. Like, you can start with an SDK and then slowly replace more and more parts until you get it as a full API gateway.
Okay, so the other question was, the handler is not available yet, the FHIR handler. So if I look on the list of available handlers,
so it is available. It's just you need to check the GitHub and not the website. We had in the last couple of days, we need to fix something of the script that generates the docs and deploys them, but in GitHub is available together with the example that I shared. The website, we'll fix the website today or tomorrow, but it's there.
Okay, so the following question is, are GQL mutations also supported?
Yes, good question. So yes, it is supported, and not only mutations, but subscriptions as well. But that's a whole different discussion, and that's part of the things that we actually want. Why I'm here today, like, we have a number of clients with a number of different use cases. We think and know that they can do much more with this. So, for example, listening to events and turning those events into live events and to real-time events, and to turn those into GraphQL subscriptions, and then also enrich the data, because in GraphQL subscriptions, you get to subscribe to an event, but then also you can enrich the data with more data that you want thanks to a query. So if you have use cases like that and you think you need those, talk to us, because we are doing it with many different other handlers and technologies, and we think here we just want a use case. Like, one of the things that is part of our philosophies is that all the open source we do, we open source it only after it's in production. So if you have a use case for that, let's talk to us. We'll help you to build it even for free, just to put it in open source and everyone could enjoy it. So yeah.
Okay, so the next question is, given that one of the benefits of GraphQL is the reduction in the payload, does it mean that running it on the client loses that benefit?
Yeah, great question. So yeah, so this is one of the benefits, but in my opinion, and I talked more like because in yesterday talks I actually showed how GraphQL works internally. Why I think there's much bigger benefit in actually automating the data processing work. So when you run it on the client, we saw that even though theoretically you're not saving, you're not having a reduction of the payload, it still gives huge benefits for the companies that are doing that, and it's actually becoming more and more popular as the entry point adoption to GraphQL. I will also add that actually you can, have a reduction in payload even if you're doing it like that. How is that possible? You can still use all kinds of methods that usually are being used by GraphQL on the backend. You can also use them on the front end, like let's say data loader. So which when everyone thinks about it, they think about it as a technique for the backend. The reason it's possible is because you have a schema of the data and you have a query. So you know up front all the different sources that you're going to query, so you could batch them, and you can do those batching on the client. So of course you can do those optimizations without GraphQL, but thanks to GraphQL you get to automate those optimizations and just deploy them automatically to all the different users and all the different programmers. So we see even reduction of the payload even if you do it on the client, but again, that's not the main reason. The main reason is just to automate a lot of the code and just remove a lot of the manual code that you do.
Yeah, that's. I think you answered that fully. So we've got two questions which are sort of related regarding authentication. So how do you authenticate against a FHIR server that's not open to everyone? Can I use basic auth and configure something in a YAML file? And then there's a different opinion following saying you could do that per Smart on FHIR. So yeah, what do you want to comment?
So yeah, so the answer to the first question is simply yes. Like you could just pass the the mesh config is very flexible, and you could just pass like headers there, and you can configure variables there. So you can just pass the authentication. Also, yesterday there was a question of where should you handle that authentication and authorization. So you can think, in my opinion, GraphQL here serves as a smart data router. So you want to authenticate before and pass it through, and you want to like to do the authorization part on the server themselves, on the data sources themselves, because they know best who is authorized to see what. And then with GraphQL, you can get partial results. So let's say in some, I'm calling 3 different data sources. I have authorization for 2 of them. I can return partial data back, unlike REST, which I can just probably would fail on one big 400 something code. So yeah, so the short answer for the first question is yes, and the answer for the second one is also yes. Like, I mean, no matter what type of authentication you're using, you should do it prior to GraphQL Mesh and then just pass it through the config.
Okay, so there was also a follow-up on that.
Yeah, and the third one is the same. So yeah,
exactly.
You can just do that.
I think with that, then there's a question whether you plan an MSSQL handler.
Good question. So we have MySQL, we have Postgres in terms of SQL databases. MSSQL, if you need that, talk to us. We really want just a use case and to start doing that. So I think we can gradually and again, we can just open source it and make it available to everyone. Until now, we just didn't have the use case. So yeah, we would love to work with you, or if you have a use case for that, just let's do that.
Okay. So the next question.
It's not going to be an easy project, but because MSSQL has a lot of cool features, but we can also, it could be a gradual project. Like we could probably very quickly give you a very simple SQL to GraphQL converters, and then slowly add more and more features that MSSQL has.
Okay, so the next question is asking for more explanation on mutations. Could you touch on that?
Yeah. So so mutation is basically like an RPC. So yeah, like kind of a post request. So you can you basically like ask for an action. The interesting part about GraphQL is a mutation comes also with a query. So as the client, you can say, okay, I want to, let's say, call the add user mutation with those parameters. It will add the user, but then what I can ask back is when it's ready, like when it's done, I want to get back not just like, let's say, a random 200 OK from the server or whatever the server arbitrarily decided to bring me back. I can ask for, let's say, the ID of the new user or some data on the new user, so I can introduce it back to my local store and get an immediate response, or all kinds of things like that. So I get to query together with the action, so I can decide what I want to get back, which is very useful for a lot of mobile applications and more interactive web applications, because all of those applications has like a local store, local data store, and now you can much easily get a better experience because you can choose the data that comes back every time you're making an action. And similar things, by the way, is happening with subscriptions, like I said before, on events, basically. Yeah, I hope it answers.
Okay, yeah, it does, definitely. Then there's a question, I'm not sure I get it. So does the FHIR handler support connection and cursor pagination?
Yes, good question, and the answer is yes. It's actually because the FHIR, it's thanks to the FHIR protocol's ability, it's actually a bit similar to the old data handler that we wrote. Like, because the actual, like, if it was just FHIR protocol was just, we would just use it as a JSON schema or something, there wasn't the concept of that. But because FHIR protocol has that concept, we could more easily and automatically translate those into those things. So yeah, so the answer is yes, but we want more and more use cases. Like all the use cases that we had today are relatively easy. We want to get more and more use cases from everyone and enhance those things. Like today with the OData handler, for example, because of all the different use cases that we got from Microsoft, there's a lot of cool logic that we're doing there for connections and for pagination and all those things. So, yeah.
Great. So here's a good one. From the animation slide on GraphQL, parallel working, I got the impression that we can change some complex logic in the graph nodes. If I understand right, so is the GraphQL Turing complete?
So yeah, I'm reading it as well. So it's not Turing complete because it's not supposed to be. Like we're not trying to make it like a full programming language that you can process anything with it. It's just more of a query language, and we want to keep it simple for specific things. There are some, I visited actually in December last year, I gave some talks in China and visited Alibaba, and they built some cool extensions over GraphQL that made all kinds of new things possible. It depends on the use case. Like we're still looking, the whole community is looking into more and more use cases. In the foundation, we try very, I would say, we're very cautious at adding more and more features. So as we see more use cases, maybe we'll grow into something like that, but yeah.
Okay, so we've got, let me see, just check the time. We've got 1 minute left. Oh. So I'll just say, can this tooling be used to extract the TypeScript typings from a particular FHIR server for a type-safe client?
Can this tooling be used to extract that? Yeah, exactly. So We are also the creators of the GraphQL code generator that basically can generate basically anything from GraphQL schema and queries. So not only that it could generate typings for your resolvers, for example, and in this case TypeScript typings, but also it can look at your queries, understand the results it's going to get, generate the TypeScript typing for them, and more than that, we even can generate, let's say if you're using React, we can generate ready-made React hooks, or if you're using Angular, we can generate Angular services or a Vue. So we have integrations with all of those. So yeah, that's definitely one of the most powerful tools. Once you get into the GraphQL protocol, into the ecosystem, GraphQL code generator is one of the, I guess, maybe even our most famous tool today. So, and we have dozens of plugins, most of them in TypeScript. So yeah. It's a good question.
So great, Yuri, I think you really planned this out well, answered quite a lot of questions. So I'd love everyone to rate this talk. I think it was great. We'll stay in the call for the next 5 minutes, so we might be able to answer a few further questions. I think they'll only be able to answer by typing in the chat box. I'm not sure the voice will keep on, but I'll stay in here for the next 5 minutes with Yuri. Thanks all, and enjoy the remaining dev days.
Thank you.
Great, Yuri, again. So yeah, thanks. So these guys are so let's just wait for those thanks to pass through and we'll see who stays on for questions.
Yeah, I saw there's more requests for MS-SQL, so the MSSQL, and yeah, for sure, feel free to reach out. Like my email is public on my GitHub. I'll just write my GitHub profile. My email is public there, so like just feel free to reach out and ask questions. And for MSSQL, we want to do it for a long while, and we just need use cases. We just need someone to like tell us what they want and help us test it. Yeah, and I think there's a big ask for it, so for sure.
Yeah, definitely. I think I'll get back to you on this. So let's just. So I'll copy these. I'll just copy these out here of the chat, and I'll send them to you.
Okay. Yeah.
Because I'm not sure they're going to be archived. So we'll just. So how long have you been working on this, Yuri?
Well, I started on GraphQL in general. I started pretty early because I used to work in a company called Meteor turned into Apollo, and it was a JavaScript platform, open source platform, and we started thinking, what will Meteor 2.0 look like? And then it was the exact same time that, and we had like our own open source protocol because again, REST wasn't enough for us. But then at exact same time, Facebook open sourced GraphQL. So we were basically like the first ones jumping in. And basically today, the whole company shifted and did a pivot from a JavaScript framework to basically just a GraphQL-based company.
Okay.
So I worked with Facebook also on the GraphQL subscriptions protocol and the spec. And on GraphQL Mesh, it's an idea that I had very early on, but I had a lot of examples and ideas and playgrounds, but I got the first chance to use it in production, I think 1.5 years ago or 2 years ago. And after it was in production for, I guess, 6 months or even more, then we open sourced it. And yeah, and that was, I think, about 1 year ago, something like that. So yeah.
So how long does it take? How long does it take to implement to support for a specific query language, more or less?
It depends. So what we always try is we try the most simplistic thing possible to get people start working on it, and then the feedback and the issues will start flowing. And then it's just gradually improving all the time. That's how we do it all of our open source. One of the things that we like, our philosophy of open source is very different than a lot of the startups I used to work with that are open source startups, mostly because instead of like coming up with a genius idea and then putting it out there, and we just, all of our libraries, we daily maintain them for years and years and years. So the idea is to just constantly, slowly improve instead of, and it's very, and apparently it's very rare in the open source world to have like a group that just maintains a certain library for 4 or 5 years every day. So that got us, that's our unique advantage, that it's not like we're geniuses and smarter than everyone else. We're just, every day we keep solving issues on this stuff. So after a couple of years, it just becomes very good and very battle tested. And so same here, like you start with one, for example, the OData one started very simple, but now after Microsoft is using it and our work with Microsoft is like very battle tested now. So it's just, that's why we also open source only things that are in production, because we have a reason to work with it every day and keep improving it every day for long term. So
do you have an internal stack where you actually relate? So I was involved in D2R, where you could actually allow D2 query. You would basically translate Sparkle to a relational database query. And it was an internal abstract structure. So I was sort of wondering whether every time you come up with sort of a new new query translation, whether you use a sort of stack which, so is that tooling available for people to work with that?
Yeah. It's a great question. So yeah, we have, it's kind of like our internal abstract AST that we work with. Or intermediate AST that we work with, and yeah, it's all those toolings are also open source, and some of them. So we have both we have it on the GraphQL Mesh side, but also someone mentioned the GraphQL code generator. We also have it for the GraphQL side, because like, for example, the tools that come just with GraphQL JS, like the reference implementation to work with AST, are not the best, but we added a bunch of things and they're all open source. So if someone wants to get in, we're happy to expose them and help people. And yeah, we definitely, maybe we need to even extract some of those tools out of the GraphQL code generator and out of the GraphQL Mesh into another, like, more, AST tools over GraphQL, and also expose like this intermediate language that we kind of like came up with. So it's all there in open source, but I guess we don't talk about it too much, but it's there. So if you want to dive in, let's talk. I would love to show you everything.
Yeah, because I think this will scale the more adapters you have for different query languages.
Exactly.
So. Good. So I think we don't have any further questions here. So we left a few questions unanswered.
Okay.
You could possibly want to answer them here, but I'll just try and copy out everything.
Oh, okay.
Let me see if I manage to do this, to export the whole chat. Let's see if this works. And let me just see. Yes, Zoom is sort of really crashing my computer.
Yeah, that's when I started actually like doing the example, everything froze. So I'm happy that like I had a bit of a video, and I am happy it's available on GitHub so people could just try it out and don't need to rely on me to run it.
Okay, So I can't really export this chat, which is sort of a pain. Let me just check. No, that's a pity. Let me just check. Oh, some are new. There's some new. Should be able to save it. Somebody's saying. Julia, cut and paste the chat. Yeah, I'm trying to do that too, but it doesn't work.
Let's see.
Let me just see. And then I say, it just doesn't let me copy. Let me just see what he's saying. You should be able to save it, more buttons. Yeah, I'm just trying that, but they say, no host, you haven't, yeah. Doesn't seem to be available here. I'll just check.
Yeah, also the problem is that my copy pasting from here doesn't work. So that's
yeah, exactly. Exactly. So even if I go on the more button, it doesn't work. I'll actually, before we actually, before I close this, I'll ask in the
yeah, maybe in the global chat.
Like, yeah, in the global chat.
Yeah, and also in general, I can be available for anyone. So both here and online.
Yeah.
And so yeah.
Exactly. Good. So I think I'll end the session now.
I think someone actually. That's cool.
Oh wow!
Thanks.
Wow, who is that? That's great.
That's very nice. Okay, I have to leave now, but thanks
so do
very much. Yeah.
Thanks a lot, Yuri. I'll be catching up with you.
Yeah, I would love to. See you soon.
Bye.
Bye.
Bye.